Hello and welcome to my channel. In today's session we are going to see how to interface 4x4 matrix keypad and to display its key code in an LCD. So before I proceed up with the program explanation, let me give a brief introduction to the keypad and LCD. LCD stands for liquid crystal display, and as per the diagrams you can see here, LCDs are available in 16x2, 20x4 and 32x8, which means 16 characters and 2 rows for 16x2, 20 characters and 4 rows for the 20x4. So in our experiments we are making use of 16x2 LCD. So you can see here the pin number 1, 2 and 3, which stands for ground, VCC and VW. Okay, so this is a contrast VCC power supply and ground, and after that you can see pin 4, 5, 6. These are all called as command lines, and which is connected to register select, read write and enable. And we have the pin from pin 7 to 14 are all data. Okay, this is used to pass the data from DB0 to DB7 here. Okay, and the last pin 15 and 16 are used for backlights. As you know that LCD does not emit light on its own, it requires some back source to display the characters on the screen. Okay. We have connected the 3 command lines, as I told you, the RS, RW and EN to the port 0, 9th pin, 10th pin and 11th pin of LPC2148, and data lines connected through port 1.16th pin to 23rd pin. This thing we should remember. In our experiment we had connected the 3 command line signals to port 0, 9 to 11 and data lines to port 1, 16 to 23 pin. Okay, now the command lines, the register select RS or read write RW and enable EN, these are used to write the command, and also it is used to write the data to LCD. Okay, see, before I display any character in an LCD, I should provide some suitable command, that is called as LCD command codes. Okay, once I do that, then only I'll be able to write the data, so that I can put the data in this data bus. Okay, starting from 0 to 7, and we should provide the suitable LCD command codes. Then only we'll be able to display each and every single character in an LCD. Okay, that's the reason I told you that it is used to write command and write the data. So to write the command and to write the data, we have certain bit codes. So for example, if I make this register select as 0 and RW as 0 and enable as active low, that is 1, so 001 means I will be able to write a command to LCD. Similarly, when I put RS to 1, RW to 0 and enable to 1, okay, 101, if I do that, then I will be able to write the data to LCD. Okay, so these are used to provide respective signals to the LCD and to display data in a LCD. Okay, so in order to display characters in LCD, it requires a 5x7, that is 35 crystals it requires to display the characters. Now let me show you the command codes which I was talking about. So these are all the command codes which we pass through the 3 command line signals RS, RW and enable. Okay, we have 1 for clear the display screen, we have the command code 2 for return home. Okay, and of course for 4 and 6 you can see for increment and decrement of the cursor. Like that we have all the hex codes here. This is used as a command signals which are going to pass it to the LCDs. Fine. And in our experiment we are going to connect the LCD to FRC2. Okay, we have certain FRCs, that is flat ribbon cables. FRC 1, 3, 4 and 5 are having 10 slots, that means 10 pins it has, and FRC 2 has 16 pins. So we are connecting LCD to FRC 2. Okay, that is here. So among the 16 pins we are using 9, 10 and 11. 9, 10 and 11. Okay, and we are using P11, P16 to 23 as a data lines through port 1. Okay, so port 0 we are using for the signals, for the command signals, and to write the data we are using port 1 from 16th pin to 23rd pin. Okay, this you have to remember. And for keypad or for the keyboard we are using FRC1. Okay, for LCD we are using FRC2, for a keyboard we are using FRC1. That is from 16 to 23 here, 16 to 23. Okay, so it is very clear that LCD pins are made as a output and the keyboard pins are made as input through LPC2148. That means whenever we press any key in a keyboard, the relevant value will be displayed in the LCD. Okay, so these are the information which I was expecting you to tell about LCDs. Similarly, now we'll see the keyboard interfacing. Okay, now let me show you the diagram here. So this is a 4x4 matrix keypad. Okay, as you can see, there are 4 rows and 4 columns. We need to connect 8 lines to the microcontroller. So based on the pin diagram here, this is the architecture of the keyboard interfacing. You can see there are 4 rows and there are 4 columns here. Okay, so you can see that the columns are connected to the resistor and then to the VCC, and due to that all the columns will be 1 1 1 1. Okay, similarly all the rows are connected to the ground, so it is having the value 0 0 0 0. So if there is any intersection of the switch, you can see the switch over here, if there is an intersection of the switch in any row and column, then automatically the low resistance path will be established and current moves in that particular direction. Okay, and the respective 1 in that column will become 0. So this is the intimation that that particular key is been pressed in that particular row and column. Now to verify which of the key is been pressed in which of the columns, then we have certain codes. Okay, that I am going to show you in this diagram. You can see here. So in our experiment we are assigning the code to each of the columns. See, for example, for the first column we are assigning the code as 0 1 1 1. Okay, 0 1 1 1. So that is 7. Okay, similarly for the column 2 we are using 1 0 1 1. Okay, and for the column 3 we are using 1 1 0 1, and for the column 4 we are using 1 1 1 0. And these codes will be refreshed for every 50 microseconds to ensure which key is been pressed. So if any key is been pressed here, okay, then the respective value of that key in a row will become 0, and then it is compared with the all these codes which I told you. Okay, if it is matching with any one of these codes, then we will come to know which of the key is been pressed. Okay, so this is how we are going to write the program. Okay, now coming back to the program. So here as I already mentioned you that we are connecting LCD to FRC2 and keyboard to FRC1. So this program will give you the information on how to write embedded C program for LCD, and we have one more program for keyboard interfacing. Okay, so let me explain you the LCD program here. So the first 4 lines you can see, these are all the necessary libraries which are required to execute a program, especially the LPC214x.h. And also we had included one header file, user defined header file, that is keyboard.h, that we have written it here. Okay, so in this keyboard program we don't have the main function here. There are only 2 functions here, right, and the relevant key codes. But in LCD program we are going to embed that header file here. Okay, now at the very beginning we have to set the register select, read write and enable for the LCD. Okay, because I told you that either you can write the command or you can write the data. So both are possible here. And for each register select, read write and enable, we have to give the GPIO pins here. So as you can see here, as I told you, we have to give the connectivity for the port 0, 9, 10 and 11. Okay, now let me tell you why I wrote 200, 400 and all here. So here this pin is 0, 1, 2, 3. Okay, totally 32 bits are there, right? So I am talking in terms of bits. So this position of 0 will take 4 bits, that is 0 to 3. 0, 1, 2, 3. This is 4, 5, 6, 7. This 2 is there, no? That will be taken as a 8, 9, 10, 11. Okay, 8, 9, 10, 11 means, for example, if I make everything as 0, okay, 8, 9, 10, 11. So this is 8th pin, this is 9th pin, okay, this is 10th pin, this is 11th pin. So I told you we have to connect it these three signal to the command line signal to the 9, 10, 11. So which is the 9th pin? This one. So I need to make this as 1. Okay, and this bit will give you what decimal number? 2. That is the reason we wrote 2. Now if I go to read write, I am connecting the read write to the 10th pin. So 10th pin is this one. So I will make this as 1, this as 0. So this will give the binary representation of 4. And similarly for the enable, I am using 11th pin. So this I will make it as 1, this I will make it as 0. So this will give you 8. Okay, that's the reason why we are assigning these values to the register select, read write and enable. These three are very, very important. Okay, unless we provide the command signals to the LCD, we are not able to display any characters in that. Okay, and meanwhile we are using 5 functions here. The functions are like LCD command signal, one function we required, and data we required. Okay, then we have a delay, and then GPIO initialization to configure all the pins, and we have LCD string to send the message. Okay, because you can see it has 2 parameters. One is the address. Based on the address, it is going to display the message character by character in an LCD screen. Okay, and also you can see this array where we are written 0 cross 38, 0 cross 0C and 0 cross 06. So these are the hexadecimal numbers for the LCD command codes, as I already shown you that. Okay, look at here. So these are the LCD command codes. In the 38 means 2 lines with the 5 cross 7 matrix. 0C means display on, cursor off, and 6 means we are using incrementing the cursor. That means we are each and every time whatever the message we have, we are going to shift the cursor to the right and display each and every character. So these 3 command codes we are using it. Okay, and we are passing it to the 3 command line signals. So coming back to the main function, first of all we need to initialize the GPIO function. Okay, look at here. At present, as I told you that we are using 2 ports, port 0 and port 1, right? So port 0 and port 1, we are not going to configure any functionalities in the pin. That's the reason we had given everything as 0 here. Okay, we are using port 0 and port 1 for connecting the LCD and keypad to the microcontroller. So we need to configure both the ports as a GPIO. Okay, if you are configuring both the ports as GPIO, then don't need to give any we need to enable any kind of pins here. So everything becomes 0. Only when you want to use any functionalities like ADC or transmitter or receiver, in that case only we need to configure the pin, else everything will be 0. Since we are using 2 ports, we are making pin select 0. Okay, so as per the diagram you can see here, so this is pin select 0, this first row. Second row is pin select 1, third row is pin select 2. Okay, so first 2 rows are for port 0, the last row is for port 1. And it is very clear from the diagram that from the port 0, 0 to 15th pin is there in first, that means 16 pins, and next 16 to 31, that is another 16 pins in pin select 1. Okay, so in our experiment we are using pin select 0 and pin select 2, not 1, because we are making use of only GPIOs. Okay, and since we are using port 1 also, we are making use of 16th pin to the 31st pin. Okay, it is very clear that FRC2 is used for LCD and FRC1 is used for a keypad. Okay, now coming back to IO DIR clear. Okay, what does it mean? Means here as you can see here, we have set the value hexadecimal of 00F00E00. Okay, so that E is nothing but 1110. That means we need to configure 9th, 10th and 11th pin as output direction. Okay, so E will come as 1110, right? So we need to configure 9th, 10th and 11th pin as output direction. So as we need to provide command signals from LCD to the microcontroller. Similarly, once we give that as an output signal, okay, so 1 means output signal, 0 means input signal, and then we have to clear it. For clearing also we have to give that 111 only, because 1 means clear flag is set, 0 means there is no effect for that. Okay. Similarly, for a port 1, these 2 are for port 0. You can see IO 0, IO port 0 direction and IO port 0 clear. Similarly, we have IO port 1 for direction and clear. This is for port 1. For port 1, I told you already we are using pin 16 to 23. So 16 to 23 is this one. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So all these pins has to be set to 1. Okay, so direction flag means either 1 means output signal, 0 means input signal. Okay, so we are making all the pins as output pin, right? Similarly, for the clear also I am going to make it as FF, so that if you want to clear in later stages, that bit or that particular pin should be made as 1. Okay, so this is the GPIO initialization. Next, as per the main function, we are going for a loop for 4. Okay, 4 iterations, and we are calling LCD command. Okay, so I will tell you, this is the LCD command here, this one. So in the LCD command, we are setting the IO1 means IO port 1 pin is equal to whatever value you are sending, we are going to left shift with the 16. That means here the value is the command code. Okay, remember, whatever value is there, this is the command codes, and we need to shift it 16 times left, so that we will be able to fetch the value stored in the port 1 16th pin to the 23rd pin. Okay, right, that is what we want here. Okay, 16th to 23rd pin, if you want to fetch that, then we need to left shift it with the 16 bits. Okay, then as I told you, this is very simple code here. As I told you, now once I fetch that data, now I need to write in bit codes. Okay, 001 means command, 101 means data. Now what do we want? We want command signal. So what I'll do, I need to make this as RS 0, RW as 0 and EN as 1. To make RS as 0, I need to put it into the clear flag. So clear flag, what happens means that particular bit will be 0. Okay, so it will be 0 means CLR means bit will be 1. 1 means it is 0 only. 1 means clear. Okay, and RW also I want 0. No, then you put it in a CLR only, clear flag only. These are the register, IO0 CLR, IO0 set, IO0 DIR. These are all the registers in GPIO. Okay, but enable I want to be active low or 1, then you make it as set, IO0 set. Set means 1, CLR means 0. So now what code you got? 0, 0, 1. 0, 0, 1 means what? That means we are going to send 3 command line signals to the LCD to that particular command lines we are going to send it. Okay, and after providing a proper 50 milliseconds delay, we are going to clear the enable flag also. That means we are making it as 0. That means we are done with the sending the command signals to the LCD. Now what do we do? What do we need to do next? We have to go for a LCD data. Means once the command line signals have been sent successfully to the LCD, the next job we need to do is to send the data. Okay. Now as you can see in the main function, this has to be repeated 4 times because 4 columns we have, right? Okay, 4 times we have to send. Then we are calling LCD STR. Now it's time to send the data. What is the message we need to display it in LCD? Matrix keypad. And this is the address 80. Okay, this is the address. Okay, 16th pin we have to make it as 1. Similarly, LCD STR C0. This is for the next key pressed. Okay, 1100. This is 1000. This is in the first row. This is in the second row. To display this message in the first row and second row, we need to send the address. This is the address. Now let me take you to the function what is there in LCD STR. In LCD STR, you can see the first parameter is address, that is what we sent there. Second parameter is a message. Okay, so this LCD STR, what it does means it will take the length of the character here by using string length here. Then I am going to take that length and we are going to pass 1 by 1 data, that means 1 by 1 character to the LCD data function. Now in the LCD data what it takes means it takes 1 character, it goes for an iteration, it should be here. It goes for an iteration. Now you see, as I told you that in LCD data also we need to take the since the value data are stored in 16th pin to the 23rd pin, we need to left shift it with the 16 bits here. Okay, in LCD command value was what? A command, right? Now in here value is nothing but a data. Now as I told you, if you want to send the data signals to the LCD, RS should be 1, RW should be 0, EN should be 1. That's the reason I wrote set here. You see in command the first was clear. This is 001, this is 101, so we need to set it. RW should be 0, so it is clear. EN should be 1, so it is set. And give a proper delay and disable the enable flag. So what happens? When you send 101, data are sent to the LCD. When it is 001, command signals are sent to the LCD. Command signals are what? These are the command signals. These 3 codes what you have written. LCD command code. Okay, please remember this point. Alright, so this is how the LCD data works, and message will be keep on incrementing. This has to be done until you able to pass all the characters of that message. Okay, so this is the program for the LCD, and this is the function for delay. Delay is not going to do any task, but it simply iterates for a number of iterations. For 3000 iteration it goes. Okay, simply to provide a small delay while displaying the characters in the LCD. Okay, so this is the simple program for LCD. Now let us move on to the keyboard program. So in this program we do not have a main function. Okay, so this program does not have a main function. We consider this program as a header file here. Okay, so here 01 to 04, these are all for column values. I1 to I4 are for row values, remember it. Okay, and we can see that the values have been set. 01 is equal to 0x00, E00000. So E means, I told you, it is 1110. As I already mentioned you that for each of the column we have to give some column codes, right? So we will give 1110 for this E. So this is 16th pin, 16, 17, 18, 19. Okay, it's from 20 to 23rd pin. P0, 20 to 23rd pin. Okay, so that pin we are using it for this. D means what? It is 1101. Okay, this is for second column code. B means 1011, third column code. 7 means 0111, fourth column code. So now that has been assigned to this 01 to 04. Similarly, we have to assign it for the rows also. Same code is for the rows, but here it is for 16 to 19th pin. Remember this. For the rows we are connecting it from 16 to 19. For the column we are connecting it from 20 to 23. Okay, that you have to remember. And then we are going to define the CLR to 00F00000. Okay, so what does it mean here? This is to clear the values of the column. Clear the values of all the columns. And we have three functions here, LCD STR. That function we have written already in the LCD program. Delay program we have, that also we have written it in LCD. Only the scan function is new in this program. Scan, we are taking the status of the key. That means to scan which key has been pressed. Okay. So you can see in the keyboard function, we are going for a iteration here, for a multiple iteration. That's the reason we have written entire code inside the while loop. Okay. It keeps checking which of the column is affected or which of the row the switch is pressed or not. Okay, continuously it will keep rotating. And you can see the first function CLR is assigned to IO0 CLR, and 1 is set to the IO0 set. After giving some small delay, it will scan. It will scan for the first row. I1 is first row. Okay. Now in the scan function, we'll see what is there. If it takes the first row, it will check for that IO0 pin. Okay, IO0 pin and with the 0x000F0000. Okay, if that if this is equal to the key status, whatever the key you had given, then definitely it is going to return 1. Okay, that means it will come to know it is going to scan. Okay, which key has been pressed here. Okay, you can see this F is placed in which of the pins? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Okay, 16, 17, 18, 19. I told you all the rows are connected to 16, 17, 18, 19. 1, 1, 1, 1. So one of the pin will be matching here. If it is matching, then you return the 1, else return 0 and keep checking it. Okay, so this entire scan function is used to scan the key, which key is been pressed. Okay, so here we check whether the value is in the pin. Okay, we check for its particular key status. If it matches, then it will return 1 and display the respective key value in the LCD, or else it will keep iterating. Okay, so usually this function is called for each and every row and the column. You can see it in the keyboard function here. If the scan of I1, okay, then you call this. If it is matching, then you call this function LCD put that address here, and if it is matching with this address, then 0 is been pressed. Okay, first row, first column is 0. Similarly, first row, second column is 4. First row, third column, like that. Okay, in that way it goes here. Third column is 8, like that. Okay, so 4 rows, 4 keys are there. 0, 4, 8, C. Similarly, for the second column we are using 159 ND. For the third column we are using 26 AE. For the fourth column we are using 37BF. So this is how we write the code. Okay, we need to pass the address and then the value. This is just a value. Okay, 0 to F we have, no? So that value we are going to put. All are hex digits here. Okay, so this is the code for the keypad. I hope you all understood this program. If you have any queries regarding this program, please drop your comment in the comment section below. Okay, thank you. Now let us move on to the execution part of this program. Okay, now we'll see the interfacing of 4x4 keypad, and we are going to display the key code on an LCD. You can see it here. This is a LCD interface. Okay, LCD interface, right? And here you can see the values will be displayed in row by row. Okay, and we are using 2x16 LCD. 2x16 means 2 rows and 16 columns. 16 columns means at a time 16 characters can be displayed in 2 rows. So totally 32 characters we can display. Okay, like that we have many other types. But as of now in our experiment we are making use of 2x16 LCD. Along with that we also have a 4x4 matrix keypad. You can see there are totally 16 keys. Okay, the values will be from 0 to F. Okay, you can see the values here. So this will be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F, like that. So when I press on this key, okay, that particular key code will be displayed in the LCD. Now let us see the demonstration of it. Okay, so now as we know that we have to connect FRC1 to the keypad, that is flat ribbon cable, FRC1 to the keypad and FRC2 to the LCD. FRC2 has 16 pins, FRC1 has 10 pins. So 10 pin is connected to the keypad and the 16 pin is connected to the LCD. Okay, after that, as you can see here, so in this program also we have one header file here. As I explained you earlier, we have a LCD program here, and in the LCD program we have included a keyboard. Okay, so keyboard.h header file, and the header file is here. So this header file will not have any main program. Header file will not include main program. Main program is included, main function is included only in the main program, that is LCD, and the extension of LCD.c. This is an embedded C program. This is a header file, and we know that whenever we have a header file, we need to paste that header file in the C:keel ARM folder, RV31 and INC folder. In this folder we have to copy that. Okay, I had copied it here. You can see here keyboard.h. Fine. Once we do that, we have to compile the code. Okay, go to lcd.c, compile the code, and you can see there are no errors and warnings. And do not forget to set the target properties here. This is very important. So you can see in the target we have to click on use the microlib. Use microlib.
In the output, we have to click on create hexa file. Listing, we have to click on C preprocessor listing, and in the linker we have to click on, that means we have to enable use memory layout from target dialog. So these 4 options we have to enable before we proceed further. Okay, so once we compile everything, it's time to burn the code from the processor to the microcontroller. So to do that, we required a help of flash magic here. Okay, flash magic. Select the device, COM port, baud rate and oscillator 12 megahertz. Browse for that file. Okay, browse for that file and click on start. Fine, we'll do that. So before we do that, we can see here LPC2148 microcontroller. Okay, we have to switch on the power supply. We have to switch on the power supply and switch on these 2 UART ports. Okay, slots UART 0 and UART 1 ISPs. PWM, no need to switch it on. Okay, once we do that, we are going to start burning the code. You can see that the programming, you can see the program is getting burnt into the microcontroller. It is verifying all the code, and once it is finished, we will be able to see you can see here matrix keypad, key pressed. Okay, now based on the key I press, you can see the key code in the LCD. Now I am pressing the first key and you can see 0 is displayed. Okay, now I am pressing. So once I press 1, you can see 1 is displayed. Okay, 2, 3. Similarly, I'll press the last one, F, E, a random number somewhere in between. Okay, 5. So this is how we are going to interface keyboard to the LCD. Okay, thank you.